Welcome, students. Today we're going to look at dividing polynomials, and that is a little bit of a lie because there's a lot of polynomial division that can be done, and we're not going to look at most of it. We're going to look at a very small portion, and we're also going to be focusing on a few rules of exponents that will help us with our division. So we're not going to cover the topic of dividing polynomials in its entirety. We're just going to look at a tiny bit of it. Let's jump in. We're going to start with 3 rules of exponents. And like the rules of exponents that we learned earlier, I'm going to start with an example. I'm going to use that example to demonstrate a particular rule. And then once we know that rule, we're going to apply the rule to a different example to show how it makes things much easier. Now, the first example we're going to look at that's going to give us a rule is going to be x to the 5th divided by x squared. Now, some of you might know the rule already, but it's my goal to show you where it comes from and to develop that rule. So what we're going to do, just like before, we're going to expand this out. X to the 5th means x times x times x times x times x. And x squared means x times x. Now, this is a fraction, and we know that when we have common factors in the top and bottom, we can get rid of them. We can divide them away. And the top and bottom have 2 x's in common that we can get rid of. So I'm going to get rid of those 2 factors of x. And when we do that, we're left with x times x times x, which is the same as x cubed. So how can we start off with 5 and 2 and end up with 3? Well, clearly we subtract. 5 minus 2 gives us 3. And you can actually see here we had 5 factors of x, but we got rid of 2 of them because they canceled, and that left us with 3 in the end. So this can be turned into a rule. If we have a to the n divided by a to the m, we can combine these into one exponential expression by taking the difference of the exponents and writing a to the n minus m. Once we know this rule, we can apply it to other examples. Let's look at y to the 50th over y to the 10th. Whenever we're dividing one power of a variable by another power of the variable, we can combine them by subtracting those exponents. 50 minus 10 is 40, so this becomes y to the 40th. There's no need to write out y times y times y times y times y times y times y 50 times. We can just subtract the exponents and we're good to go. Okay, that was the first rule. Now let's look at another example, and we're going to use this to get another rule. I want to look at x cubed divided by x cubed. And we're actually going to look at this in 2 different ways. So I'm going to write it twice. Now, if we have x cubed divided by x cubed, we can use the rule that we just learned that said that we have to subtract the exponents. So here, 3 minus 3 is 0. So this is going to be x to the 0 power. However, we can look at this in a different way. Whenever we divide something by itself, we always end up with 1, right? 10 divided by 10 is 1. 12 divided by 12 is 1. A million divided by a million is 1. Anything divided by itself is 1. And so we can conclude, because this expression is equal to x to the 0, and it's also equal to 1, that must mean that x to the 0 is also equal to 1. This is an important rule that says anything to the 0 power equals 1. There's one exception, except 0 to the 0 is undefined. But otherwise, anything to the 0 power is equal to 1. So if we wanted to take 326.7 to the 0 power, we would get 1. If we wanted to take 1,364,523 to the 0 power, we end up with 1. All right. That's our second rule. We have one more rule. And the example for this rule is going to be x over y to the 3rd power. Now we know when we raise something to the 3rd power, we're multiplying it by itself 3 times. So this means x over y times x over y times x over y. And when we're multiplying fractions, we multiply straight across. So in the numerator, x times x times x is x cubed. In the denominator, y times y times y is y cubed. Can you tell me what effectively happened to that exponent? It was distributed to both the top and the bottom. And that is our third rule of the day. If we have a fraction being raised to a power, we can distribute that power into the numerator and also the denominator. We don't have to write it out as a repeated multiplication. So if we have something like x over 2 raised to the 4th power, we can distribute that exponent and write this as x to the 4th over 2 to the 4th. And because we can calculate 2 to the 4th, we're expected to do that. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So we end up with x to the 4th all over 16. Now these are 3 new rules of exponents that we have, in addition to the 3 rules of exponents that we had before. And this allows us, just like the other rules, to simplify exponential expressions where we might have a variable written twice, and we can combine them so the variable is only written once. It also allows us to get rid of grouping symbols. There are a whole bunch of different scenarios where we use these different rules, so it's imperative that you click on the link to the other videos and you go through every one of those examples and get really comfortable applying these different rules of exponents. In the next video, we're going to use some of these rules and actually get practice performing some polynomial divisions.